well, maybe we'll forget because this couple of days ago, we go through these special angles. So what are special angles? The first group of special angles, they are angles with multiple of 90 degrees. They are the angle on the x-axis or on the y-axis. We use the unit circle to help us to work out the value. For example, I need sine 180 degrees. First of all, I see where's 180. I know it's on the negative side of x-axis, and I have intersection of -1 and 0. So y value represents the sine value. So sine 180 will be 0, cosine 180 will be -1. That's how we find the special angles for the first group of special angles. And there are a second group of special angles. And why they are special, I have explained. Because the sine, cosine, and tangent value are in a nice form, like √3/2, 1/2, they are in some really nice numbers. And you can express them out as the exact form. Okay, how do we find all of that angles? I give you two different triangles. I give you isosceles right angle triangle, and I give you the length as 1, 1√2. Also, I give you another equilateral triangle, and I cut it into half. I have the 60 degree and 30 degrees for this triangle here. Okay, for this triangle here. So I give you the 1, 2, and √3. That's the 30, 60, and 90 degree right angle triangle. By using these two triangles, I can find out the sine, cosine, tangent ratios for 30, 45, and 60 degrees. Well, I saw everyone complete this table. I just checked answer with you. Not going to go through how to do, well, one example. For example, sine 45. So what's sine 45 degrees? That's 1/√2. And if I rationalize the denominator, I have √2/2 because it's the opposite over the hypotenuse. That's the 1/√2. So I have √2/2. Okay, so the values we have here is 1/2, √2/2, √3/2. The second row we have √3/2, √2/2, and 1/2. And I have 1 here, I have √3 here, and I have √3/3 here. So just check your values. Do you have the correct table? Okay, just let you know, these values will require you to memorize it in VCE. Okay, will require you to memorize these values. Well, for example, I ask you, sine what give you a half? You should answer sine 30 degrees, or sine pi/6 will give me a half. Okay, so you need to remember these values. What's cosine pi/6? You should answer that's √3/2. So 30 degrees is a pi/6, 45 is a pi/4, and 60 is a pi/3. So that's what you need to remember as well. Well, you need to remember both the degree and both the radian form. What's pi? Pi is 180 degrees. So 180 divided by 6 give you 30. 180 divided by 4 give you 45. 180 divided by 3 give you 60. A lot of students have difficulty to remember this. Okay, for example, it's really hard to remember what's sine 45. The way I remember this is, well, the angle is arranged in a way smaller to larger, 30, 45, and 60. And this ratios is given by sine, cosine, and tangent. I set up a table first. Okay, let's see the rows. Okay, first row. Can you see the first row have a half, 2, 3/2. So it's √1/2, √2/2, and √3/2. So that's how I remember that. If I can't remember special, like a single values, I can remember this table as a whole. And before the start of exam, I can just write this table down quickly on the paper, and I can always check this table. So how you can make sure this table is correct? So 30, 45, 60, sine, cosine, tangent. In the first row is √1/2, √2/2, and √3/2. For the second row, I have the flip way, √3/2, √2/2, and √1/2. Okay, so I can remember the first two rows. So smaller to larger, larger back to smaller, exactly same values. And then the tangent is always the top divided by the bottom. So sine divided by the cos. So that's the formula, sine divided by the cos. So that divided by that give you 1/√3. That's a √3/3. And then I have 1, root 2 over 2, I have 1. And then that one I have root 3. So I can divide it to give me the last row. Also, there are like root 3 and 1 over root 3, and there's a 1. So it's quite easy to remember as well. So I can, if you can't remember single values, like what sign pi on 6, if you can't remember that, you better remember this table as a whole. And when you do questions, you write this table down. Because for this test, you have the calculator. You can always find what sign 45, what sign 60. I can always do that. But in actual VC exam, part 1 is without cats and nose. You have no information about what's going on here. So it's better you either remember the triangle here or you remember this table directly to give you the special angles. Okay, so I just introduced the way how I remember things, and well, I can remember single values, but I think students will find this difficult, so I introduced this whole table method to remember it. Root 1, root 2, root 3 over 2, root 3, root 2, root 1 over 2, and then top divide by bottom to give you the tangent. You can in maybe 30 seconds to finish this table here. Alright, so that's these special values. So 30, 45, and 60 degrees, they are these special values as well, because they can give you exact form of sine, cosine, and tangent. But not only those 3 angles are going to be exact. Okay, not only those 3 angles are going to be exact. There are some other things. Okay, then I'm going to introduce something called reference angle. Okay, a reference angle. So what is a reference angle? A reference angle sometimes is called a related angle. It's the acute angle that helps you to relate sine, cosine, and tangent to the first quadrant value when the theta is not an acute. For example, what that means, I want sine 120. Okay, I have no idea what's 120 degrees. I want to change this 120 to some smaller angle in the first quadrant to give you the same thing. Okay, to give you the same thing. So what's the reference angle? How do we find reference angle? Okay, reference angle is to draw the angle line in the Cartesian plane. Let's do the reference angle for 138. For example, find the reference angle in the first quadrant. So let's have a think. 138, can you draw this out and tell me where is it? Which quadrant that's in? Okay, which quadrant you have 138? Second? Do you mean second? Yeah, second. Okay, so which is here. So we have, well, I don't know the exact the size, but it's about 138 in the second quadrant. Okay, what is a reference angle? I have the angle line, right? And also have x-axis. The acute angle formed by the angle line and the x-axis is called the reference angle. So what is it? The reference angle is the angle line and the horizontal x-axis form an acute angle, which is this one. So that will be the reference angle. It's always the same. It's always the angle line made with the horizontal x-axis give you the reference angle. So this is my reference angle. What's the size of this angle here? Okay, 42 degrees. So the reference angle is 42 degrees for 138. What I can say here is, what is a reference angle? Reference angle is sharing the same kind of ratios with 138. So 42 and 138. Well, I'll talk about more about this later. But I'll say 138 got a reference angle of 42 degrees, and it's kind of the same thing. It's kind of the same thing for each individual ratios. So when I talk about sine 138, it will be the same as talk about sine 42. Okay, it will be the same as talk about sine 42. It's about the symmetrical properties, but I'll go through that later. Let's keep finishing this question first. Okay, can you draw 227, please? Okay, 227, where is it? 227. Which quadrant do you have that? Third. Okay, it's about here. So from the 0 to here, I have 2 to 7. Okay, this is 2 to 7. So where is the reference angle? This is the reference angle. Can you see that? This is the reference angle because it's the angle line made with the horizontal x-axis. Okay, horizontal x-axis made with the angle line. So this line and the horizontal give you this angle here. That's the reference angle. That's the reference angle. So I will use 227 minus 180. That gives me 47 degrees. And that gives me 47 degrees. I'll talk about that later. We first of all learn how to find it, and then you will see why we do it. Because it's hard to talk about sine 227 degrees. What is it? You have no idea about that. But it will be quite equivalent to talk about like sine 47 degrees. Okay, I'll show you this in the unit circle later. But let's finish doing the reference angle first. Okay, 302. Where is it? Where is it? Which quadrant? Okay, false. False quadrant we have about here. Okay, so this one is 302. So reference angle will be the angle made with horizontal, which is this one. That's a 58 degrees. Okay, 360 in total. I use 302. I have 58 degrees here. So the reference angle is for 58 degrees. Okay, let's have a look. Why I talk about this? Okay, why I talk about this? Let's draw a unit circle. Well, let's draw 180 minus theta. Let's think about theta is an acute angle. Okay, just draw this circle here. Well, remember we have the unit circle thing. Like that's the, well, you know, symmetrical unit circle, symmetrical thing. And I will draw a theta and I will draw a 180 minus theta. Okay, I'll draw a theta and I draw a 180 minus theta. So my theta, say, which is here, this is theta. Okay, this is angle theta. Can you see if I have a symmetrical one, this will be 180 minus theta. Yeah, like this must be theta. So this is symmetrical. Can you see that? This is symmetrical about the line y-axis, about y-axis. Also, the reference angle here is theta degrees. Okay, the reference angle is theta degrees. This is theta. Okay, I ask you a question. If the coordinates here, this coordinates is A, comma B. Okay, what's the coordinates here? Similar. Minus A, comma B. Okay, x value and y value represent what? X represent what value? Cos, and y represent sine. Okay, so what I can see here. Okay, A is cosine, right? Cosine theta. B is sine theta, right? Okay. Minus A is what? Is cosine 180 minus theta. And B is sine 180 minus theta. Because it's the definition. The definition for unit circle. How do we define sine and cosine? The x intersection is the cosine, y intersection is the sine. Okay? Because that's the angle. That's the angle. That's 180 minus theta. That's the actual angle. So this is the line of the angle. This is the reference angle theta. That's not actual theta angle. This is the 180 minus theta angle. This is a theta angle. Right? This is the theta, this is the 180 minus theta. This intersection, well, ignore the A and B. The x intersection is the cosine 180 minus theta. And the y value is the sine 180 minus theta. Because they are symmetrical, the reference angle theta, which is the same as this angle here. That's why they are symmetrical points. And we have minus A and B. Can you see the sine 180 minus theta is equivalent to sine theta? So sine 180 this equals to sine theta. That's how we use reference angle. Can you see the reference angle has been used here? I have changed 180 minus theta to a sine theta. Okay, to a sine theta because it's the same. See, sine 180 minus theta is B and sine theta is B as well because they have the same height and it's exactly the same. For cosine 180 minus theta, that will give you minus cosine theta. Okay, that will give you minus cosine theta because minus A and A. Okay, they are the negative of the relationship. They are the negative of the relationship. So it's the negative cosine theta. And also if you can think about the tangent, if you can think about tangent 180 minus theta, that's the sine 180 minus theta over the cosine 180 minus theta. And you know the sine 180 minus theta can be changed to sine theta. Cosine 180 minus theta will be changed to minus cosine theta. So that will give you a minus tangent theta. Okay. So it has been changed to reference angle as well. Can you see all the angle 180 minus theta in the end become a theta? It's only where there's a positive of that ratio or a negative of that ratio. The sine remain a positive and the cosine and tangent become negative of the actual ratio. So that's why we talk about reference angle. Okay, that's why we talk about reference angle. But let's have a think. Why sine 180 minus theta is positive? Do you remember the cast? Okay, which quadrant is this one? S, right? Is the sine quadrant. That's why the sine will remain positive and cosine and tangent will all become negative. Because the cosine and tan value in sine quadrant will be negative. It's only sine will be positive in this quadrant. Okay, that's the theory, and that's how you work on those formulas, the three symmetrical property formulas here. You will investigate more like later next year. But okay, how we use it is the key point. Like, it's very important to see how we use it. Okay, I want to evaluate this, but I have no idea on what's 120. It's not a multiple of 90 degrees. Also, I can't see 30, 45, and 60. Okay, so what I will do first is to find the reference angle of this angle 210. That's the first thing, how I want to evaluate that. So I want to find, I'll just go through this first. Okay, and you can see why we talk about reference angle. 210. 210 is approximately here. Okay, that's 210 degrees. So what's the reference angle? There are two steps to evaluate things. Okay, there are two steps to evaluate things. So what's the reference angle? That's my first step. The first step is to find the reference angle. The reference angle will be there. That is a 30 degree. Okay, that's a 30 degree. So the first step is to replace the actual angle by the reference angle. Okay, the first step is to replace the reference angle by the original angle by the reference. So what I'll do is, this is become cosine 30 degrees. Not finished. Okay, not finished. What I'll also do is to see the quadrant. Whose quadrant is this one? Tan. Okay, we have the tan quadrant here. So cosine will be negative. So I will add a negative in front. That's how we evaluate that. So cosine 210 will become negative cosine 30 degree. And you know 30 degree is something special. Okay, you can't evaluate that. So cosine 30 degree is minus root 3 over 2. Okay, if you can see the table before, What's cosine 30 degrees? That's a root 3 over 2. So it's a minus root 3 over 2. Well, it's always 2 steps. Okay, it's always 2 steps. First step is think about what's the reference angle. We change the actual angle by the reference angle. The second thing is to think about whether it's positive or negative according to the cast, okay, according to CAST. So whether it's positive, well, if it's the positive quadrant, you add a positive sign, well, it's just positive. If it's negative, you add a negative sign in front of that. Okay, can you try the next two by yourself? Okay, can you try B and C by yourself? Through that again. Okay, 115. I'm waiting for you to stop talking, please. Okay, 150 degrees. So here is 150. Well, in the second quadrant. And you know the reference angle is here. Well, this is 150. Okay, this is the actual angle. And your reference angle will be the one made with horizontal, and that's a 30 degree. Also, you know this is the sine quadrant. Sine will be positive. So first of all, I will change the sine 150 to a sine 30. That's changed into a reference angle 30. And also we test the quadrant. Well, sine 30 now is a positive value. Do you think sine 150 should be positive or negative? Is in the sine quadrant, it should be positive. So we keep it as positive. So that one equals to a half. So for 150, sine 150 equals to sine 30, and that's a half. The next one is tan 330. Tan 330 is here. Okay, tan 330 is here. So 330 is this one here. So reference is the 30 degrees. Okay, reference is that 30 degrees. So first of all, I will change tan 330 to tan 30 into the reference. But this quadrant belongs to the cosine quadrant. So tan needs to be negative. So we put a negative in front. Because tan 30 is a positive. Remember, any acute angle, sine, cosine, tan will be positive. So now I need a negative number overall. So I add the negative sign onto that. And that gives me negative root 3 over 3. Okay, that gives me negative root 3 over 3. Alright, let's have a look at the third example here. Okay, so how we should do for the third one? So to choose an obtuse, well, give us the obtuse angle. I can find what the reference angle should be, right? Give me the obtuse. I can find out what acute angle I need to change it to. But now it's giving us the acute angle to ask us to find the obtuse angle. So sine 30 equals to sine what? Well, let's have a look. Because it's positive sine and positive sine. Positive sign and positive sign. So I need this O and I need this S because it must be in those two quadrants. If it's in those two quadrants, I will have both positive. Okay? So sine what should equals to sine 30? Well, if you can think about sine 30 is here. Okay, I want a reference angle of 30 degrees in this quadrant as well. So I can go for this one. So give a 30 as well. Okay, to make this have the reference angle of 30 degrees. degrees. Well, the angle, if you have the same reference angle with the acute, it will give you the same ratio. Therefore, the actual angle here is 150 degrees. Okay, so here I will have 150. Okay, here I will have 150. No? First line, yeah? 180 minus that? Oh, this way? This way?
Can you go straight from there? Here?
Here? From here?
From there,
Here?
yeah, that's one thing.
But like it's not making sense. You know when you measure angle, you always measure from here. Well, it's the same angle, you're right. But you always measure the angle from here. You can't measure angle from the air, like here. It's the same angle, it's the same size, but like it's not the same reasoning. Like when you measure angle, you always need to measure from the positive horizontal to this side. Also, be careful with the question. It's ask you for obtuse angles. Well, there's more than one angle will give you the same result, but I want the obtuse angles, so it can only be in between 90 to 180. Okay, only can be in between 90 to 180. Okay, the next one is cosine, negative of cosine what equals to cosine 57 degrees. So I can treat this as cosine what equals to negative cosine 57. Okay, cosine what equals to negative cosine 57. I can change my question into that as well. So I need obtuse angle. So I need angle in between 90 to 180. So it will be in the second quadrant. Okay, it will be in the second quadrant. So 57 degrees is here. So I want in this quadrant to have the symmetrical angle with the same 57 as the reference. So the actual angle we have should be this one. So it's 180 minus 57. So I can say that's 123 degrees. But because it's the sine quadrant, that's why we will have the negative. Okay, that's why we'll have the negative. Should equals to negative tangent 81. Okay, tangent what equals to negative tangent 81. So same thing, we have 81 here. That's the 81. The symmetrical will be here. Okay, here is 81 degrees. This one will give you 180 minus 81. So that will be 99 degrees. Okay, a little bit over that side because I need a reference of 81 degrees. Also, I need the negative because it's the sine quadrant. I need a negative 10. So I change 99 to 81 as the reference angle, but I need the negative values in front of that. Be careful, like you can have infinite many solutions here, but because I'm asking for obtuse, that's the only value here. I can also select an angle, for example, here for this question. That can give me a negative 10 as well, but this is not the obtuse angle anymore. So I can only select the second quadrant value. Okay, I can only select the second quadrant value. All right. For the next one. Okay, for the next one. Well, next one is just basically reference angle. If you want to choose an acute angle to complete the following, well, 125. Okay, 125 is here. Okay, so we have the reference 55 degrees. Because it's the sine quadrant, I can directly change it to sine 55. Okay, directly change it to sine 55. is the sine quadrant here? Well, this question, I can say that's a cosine 235 degrees equals to negative cosine what? Okay, if I make it this way, it's better to see, okay, what's going on. So 235, which will be here. Okay, 235 in the third quadrant. Well, this is the tangent quadrant. Okay, it's in the tangent quadrant. That's why we have the negative. That's why we have the negative. Now I want the angle here. So I minus 180. So I have 55. I have 55. So minus 180 gives me 55 as the reference. So I change this angle to the reference angle because it's the tangent. That's a negative. Okay? Because it's the tangent, then that's a negative. That's what we'll have. Okay, tan 320 to a negative tan what? Okay, a negative tan what? So 320 is approximately here. Okay, that's a 320. Sorry? You can put the negative there. It doesn't matter because you times negative 1. Or you can times negative on both sides of the equation. It will be the same thing. Like, you just move the negative 1. So that's the 320 is the cosine quadrant. And with a reference angle of 40 degrees. So the 320 will be changed into a 40 degrees. And it's the cosine quadrant. And I have the negative there. Okay, and I have the negative there. So it's a negative tan 40. Okay, so I can go back to change. Well, that's a 40 degrees and that's a 55 degrees. So the same thing. Well, because I put the negative on the side will make more better understanding here. I can see why the negative is there. Okay, because I changed the reference angle and I put a negative. It's not the tan quadrant in the fourth quadrant. So I put the negative there. Okay, so this is the type of questions why we need reference angle. Reference angle can replace the actual angle directly, make it into a smaller angle, which makes better understanding. Well, I understand 0 to 90 degrees sine, cosine, tangent, how to calculate that. I can use right angle triangle to help me. And whether it's positive or negative depends on the cast, CAST. That's how we use the cast as well, which quadrant it belongs to. Let's do the last question here. The last question said, state two values of theta. Okay, sorry, like I need to change this question. State two values of theta in between 0 to 360 degrees, not 180. Okay, in between 0 to 360 degrees, given that cosine theta equals to negative root 3 over 2. Okay, cosine theta equals to negative root 3 over 2. Okay. First of all, my question is, cosine what give you root 3 over 2? Positive. 30 degrees, right? 30 degrees. Okay, I need a negative root 3 over 2. Doesn't matter whether it's positive or negative. The ratio is root 3 over 2. So the angle must be related to 30 degrees. Like, in other words, the reference angle must be 30 degrees. Okay? Reference angle must be 30 degrees. Now my question is, in which two quadrants the cosine will be negative? So 1, 2, 3, 4. Which quadrants? Second and third. Okay, so CAST, I want negative. So it must be the sine quadrant and tan quadrant. The angle must be there to give me negative cosine values, right? If I want my cosine something needs to be negative, it must be in those two quadrants. So the angle, let's just draw two angles here. Okay, cosine of something, I need to have reference angle 30 degrees as well, because I need root 3 over 2. So the reference angle must be 30 degrees. Okay, reference angle must be 30 degrees. Let's think about the actual angle. What's this angle here? What's that angle? 150? And what's this one here? 210. Okay, 180 plus 30, so 210. So the two theta value must be 150 degrees and 210 degrees. Okay, in between 0 to 360. Must be 150 degrees and 210 degrees. Because what I explained is a negative ratio I need in those two quadrants. And the ratio needs to be root 3 over 2. So reference must be 30. Okay, reference must be 30. So that's why we have 150 and 210 in this question. Any questions? Any questions? Well, that's how we use reference angle. Okay, basically this whole exercise is to evaluate all the angles, like larger angles, for example, over 90 degrees or less than 0 degrees. How we can make those angles become a reference angle in between 0 to 90 degrees, and how do we decide it's positive or negative? Depends on the cast. Okay, depends on the cast. So that's the two skills you need to have. Change angles to reference angles and decide whether it's positive or negative. Depends on the cast quadrant. And also we learned this in the end. There's the at the beginning, which is the degree to radian and radian to degree. How do we convert between that? You might be asked for some sine 4 pi over 3, something like that. You need to able to convert into degree, or if you have your own way to do it, just do that. It will be the same as give you degrees. So 4 pi over 3, reference angle will be a 60 degrees. If you can sketch that on the Cartesian plane. Impossible to be on the test. Like this exercise is a year 9 and year 10 both learn topic, so you will be involved. So accelerated. Accelerated. So you learn the same thing.
Why are you always making the cosine rule?
Because year 10 got one more lessons compared to year 9 accelerated. Year 9 got 3 periods, we have 4 periods. We can't exactly learn the same thing with them, so that's why. Well, also this is a year 10 curriculum. Like you learn this in year 10. Like the sine rule, cosine rule, and tangent rule. It's a year 10 curriculum, so we need to complete that as well. Well, it's not really being on the test because year 9 is doing the same thing as us. But it will be helpful for spec, year 11 spec. That's why we're still doing this. It's not for method. Sine rule, cosine rule is not really for method.